Hello and welcome to our YouTube channel, Quick Solvers. Here I want to find f of 10, where f of x plus y is f of x plus f of y plus x times y. And we know that f of 1 is 1, and both x and y are real numbers. I believe this is a good question for those who are preparing for GRE or GMAT and its difficulty level is medium. So let's see how can we solve this. One solution that comes to mind is that if you want to find f of 10, maybe we can start by finding f of 0 first. And well, we can one assumption is that this 0 means x and y both are 0. Then I can rewrite this according to this definition of this function as f of 0 plus f of 0 plus 0 times 0. And this is telling me that f of 0 is 2 times f of 0. And from this I can conclude that f of 0 is 0. Then using this and this as the basis, we try to find f of 2, f of 3, f of 4, and then all the way down to f of 10. Well, this is, as I said, this is the first solution that comes to mind, and this works. This is a good solution, of course, when this number here is a small number. But if it's a big number, like 100 or like 1000, I mean, then this is not the solution, actually. This is not an efficient solution. So that's why I'm going to go through another solution, which I think would work for the number, no matter it's 10 or 1000 or 1 million, you can easily find what is the f of that number. All right, so let's make an assumption here, or make a generalization. Instead of f of 10, let's assume that I want to find f of n. All right, and you agree that I can write n as n minus 1 plus 1. All right, then I can rewrite this f of n as f of n minus 1 plus 1. And this is pretty much similar to this, because we can assume that this part is x and this part is y. So then I can rewrite this as f of, I'm applying this definition for this function here. I can rewrite this as f of n minus 1 plus f of 1 plus n minus 1 times 1. Great, here we know that f of 1 is 1. That's our assumption here. And we know that this multiplication is just n minus 1. So this is telling me that I can rewrite f of n as f of n minus 1 plus 1 plus n minus 1. And this sum is n. Okay, so let me remove this and directly write it as n. And this is very important. I got this from this definition, okay? But since I'm looking for f of 10, then I don't need to go through this. I can just go through this one. And this is very, very familiar, isn't it? Well, we have f of n, which equals n plus f of n minus 1. And, well, f of n minus 1, following this definition, is n minus 1 plus f of n minus 2. All right, and if I replace this to this, I replace this to this, then I would say this equals n plus n minus 1 plus f of n minus 2. All right, so basically this is telling me that f of n is the sum of n plus n minus 1 plus n minus 2 plus n minus 3 all the way down to 1. All right, and that's actually the sum of n consecutive integers. So I would say f of n, then from this I can conclude that f of n is 1 plus 2 plus 3 plus 4 plus n. And we know that this equals n times n plus 1 over 2. So here I was looking for f of 10. Then I can say this equals 10 times 10 plus 1 divided by 2, which is 55. And this is the answer for this question.